Today we're going to be looking at solving equations with radicals, like the problem you see here behind me. And this is something new, but it's something pretty simple, like I'm going to show you. And how do we get rid of a root? Well, the best way to get rid of a root is to square it. Not to square the x, not to square the 7x, but to square everything that's in the root. So why don't we do that? And do you remember one of the first rules that I taught you in algebra? Whatever you do to one side of the equal sign, that's right, you have to do to the other side. And of course we don't need parentheses because there's only one thing we're squaring. We're just squaring the 4. That's the only thing on the right hand side of the equal sign. And why did we square a radical? Because the square of a square root is itself. That is to say, whatever is inside of the radical is what's going to be left. Think about that. Squaring a square root. So that's pretty simple. 7x plus 2 was inside the radical. So we squared the square root, and whatever is inside the radical is what we have left. And the right-hand side of the equation is even simpler. What's 4 squared? It's 16. And now this is looking real familiar because we've been doing it all year round. And now I'm going to do something that I told you not to do in the beginning of the year, and that's skipping steps. But after a while, this stuff becomes so familiar that I think you can skip steps on some of the easier stuff. And you know that we're going to subtract 2 from both sides. So why don't we just get rid of the 2 and make the 16 a 14? And we're going to divide both sides by 7, and I'm not going to put a 7 under that 7x, and I'm not going to put a 7 under the 14. And by the way, I'm not going to be explaining what I'm doing in the future, so you know what I'm doing. I mean, we've been doing this long enough to where you know what I'm doing. But anyway, I said anyway. 7x divided by 7 isolates the x, and 14 divided by 7 is 2. Now, with radicals, I am warning you, check your work, even your homework. And because radicals are funny, and sometimes that things that should work do not work. So let's put the original problem up there again. And we said our answer is 2, so x equals 2. Why don't we substitute a 2 in there? Good. Instead of 7x, we have 7 times 2. That would be 14. 14 and 2 is 16. And the square root of 16 is 4, so that looks real good. Now let's try another problem. Now this is a cube root, and we don't see too many cube roots in equations for Algebra 1. You will in Algebra 2. But since this is so simple, I'm going to show you at least the basics on this. And we have a cube root. How do you think we're going to get rid of it? That's right, we're going to cube it, because the cube of a cube root is itself. That is, whatever is inside of the radical is going to disappear. Now, as you can imagine, if you want to let your mind roll a little bit, the 4th root, how would you get rid of it? Well, an exponent of 4. And the 5th root, how would you get rid of it? Well, an exponent of 5. And so, well, did we forget something? Well, that's right. Whatever we do to the left-hand side, we have to do to the right-hand side. And we cube the entire right-hand side. Notice that we've cubed the entire left-hand side. So we need to cube the entire right-hand side. That is to say, don't cube the 4, cube the negative 4. Everything that's on the right-hand side of the equation. And so what do we have there? everything that was in the cube root is x minus 1, so that's standing alone. And negative 4 cubed is negative 64. Bring that negative 1 over, and x equals negative 63. And I can guarantee you, if you substitute that back into the equation, negative 63 is going to work. Negative 63 minus 1 is negative 64, and the cube root of negative 64 is negative 4, so that works. And let's try something else. And again, this is something new. Before we just had a radical, and now what do we have? We have a radical mixed with a variable, a non-radical variable. What are we going to do? Well, this is how you do this. You get the radical alone on one side, and you get everything over on the other side. Just like that, now we have the radical alone, so why don't we square that radical? Just like that, pretty simple. That's what we've done before. But on the right-hand side, we've never had two things to square before, so what are we going to do? Whatever you do to the left-hand side, you do to the right-hand side. Remember when I said that about 50 times at the beginning of the year? You thought you were going to scream if I said it one more time. I stopped saying it. Well, guess what? I'm going to say it again. Because some really simple principles that we learn, as we move along, you kind of forget, or you think it doesn't apply anymore because we're doing more difficult stuff. No. Whatever you do to the left-hand side of an equal sign, of an equation, you do the same thing to the right-hand side. So what are we going to square on the right-hand side? Everything. What did we square on the left-hand side? Everything. What are we going to square on the right-hand side? Everything. And I'm not going to go through all those steps with you. You know how to square a binomial, and what did we say? A binomial times a binomial, even a square, a binomial times a binomial is a trinomial. So if you forgot that negative 10x in the middle, that's a good little thing to remember. A binomial times a binomial is a trinomial. And I know there are exceptions to that, and I'm not going to go over them again. But you know that basically a binomial times a binomial is a trinomial. Don't forget that middle nomial. And so let's get that x squared over to the other side. And that'll become a negative x squared. And you know why we're doing this. We're trying to get all of our numbers on the left-hand side of the equation, so that on the right-hand side of the equation it's going to equal 0 once we move everything over. And then we're going to solve for that by factoring. I know I'm getting a little bit ahead of myself, but there you go. So we have negative 10x. We're going to move that to 4x, and negative 10x is going to become positive 10x, you know. And that'll become positive 14x. And 25, going to move it to the other side, will be negative 25 plus 1. And that'll be negative 24. Now, we have a problem. We have a trinomial where the x squared has a coefficient, and we don't like solving these problems when x squared has a coefficient. So it has a coefficient of negative 1. So what are we going to do? We're going to multiply everything on this side of the equation by negative 1, and that will change that to positive, negative, positive. And we're going to multiply the right-hand side of the equation by negative 1 also, but it doesn't matter. Anything times 0 is 0, so negative 1 times 0 is 0. That is not going to change. So let's tear that 24 apart. There we go. And can we add or subtract 1 and 24 to get to 14? I don't think so. 2 and 12. Yeah, if we add 2 and 12, that gets us to 14. Let's keep going. 3 and 8, can't add or subtract that to get to 14. 4 and 6 is not going to do it, so our only possibility is 2 and 12. Let's put that together. And 24 is a positive number, so 2 and 12 both have to be positive, or they both have to be negative. Let's see. Positive 12 and positive 2 gives us positive 14. We don't have a positive 14. Negative 12 times negative 2, that gives us a positive 24 and a negative 14x. Very good, and so x is going to equal positive 2. Positive 2 minus 2 is 0, so that's good. Positive 12 minus 12 is 0, so that's good. So x equals 2 or 12. And like I said, we're going to be real careful. We're going to insert both of those numbers back into the original equation. Okay, let's substitute 2 in for our x's. Remember, we have two x's. We have an x here and an x there. Okay, and I want you doing this on paper while I'm doing this in my head. 2 plus the radical. Now the radical is 4 times 2. That's 8. 8 plus 1 is 9. So the square root of 9 is 3. 2 plus 3 is 5. Yeah, that's good. Okay, so 2 is a good answer. Let's try 12. Okay, now we have 12 plus the radical. In the radical, we have 4 times 12, that's 48. 48 plus 1 is 49. Well, that's good, because we know that 49 is a square. So what's the square root of 49? That would be 7. So 12 plus 7 equals, yikes. Guess what? 12 is not an answer. 12 does not work. As you can see, 12 plus 7 does not equal 5. And so the only answer for x is going to be 2. Be careful of this, because with squares and radicals, numbers get a little funny. And we're not going to get into why that's the case. Just understand that it is the case. I mean, it's always good to check your work, but with squares and radicals, even on your homework, you're going to be checking your work, because these numbers act a little funny. Now let's try something new. Are you kidding me? We have 2 radicals now? Well, this isn't as bad as it looks. When you have 2 radicals in an equation, you get 1 radical on each side of the equal sign. And that shouldn't be too hard. Let's see, the first radical, we'll leave that alone. But the second radical is negative, so why don't we bring it to the other side of the equation and make it positive? Okay, that looks a lot better. And what do you think we're going to do? We're going to square both sides. Well, that looks good. We have a lot of stuff going on, but we have a radical over here that is squared, and we have a radical over here that is squared. And so we're just going to take the exponents and the radicals away, because the square of a square root is itself. Boy, all of a sudden that looks real simple. Let's bring this x over here. It's going to become positive x is going to become negative x, and so that'll be 2x. And moving the negative 8 to the other side. And I'm going to take this time to go over something that I have not gone over before, but it's very important. In a lot of algebra books and a lot of algebra teachers will tell you that if you take a number or a variable and move it from one side of the equal sign to the other side of the equal sign, a positive will become a negative, or a negative will become a positive. Like you saw with this negative 8 here, we moved it over to this side and it becomes a positive 8. I didn't want to go over that originally, because guess what? That's just an algebra trick. And they teach students that, and students don't know why that's the case. They know that it is, but it's just a trick. Well, it's not a trick with us, because I've already gone over why that happens. We have a negative 8 over here. We add a positive 8 to this side, a positive 8 to that side, and so an 8 pops up over here, and these cancel out. Well, you know all that now. But as long as you know that, I don't mind you using that trick. It's not really a trick because you understand what's happening. But that's very important. And it's very important that if anybody teaches you that, they need to be corrected. You need to go through it. I know it's a lot of extra steps. If you remember, when we were going through all that, it was a lot of extra steps. But it helps you to understand why all this is going on. And now when I move a -8 to the other side and it becomes a +8, well, you know what I'm doing. I'm just skipping steps is all I'm doing. I'm not really using a trick. But anyways, we have 2x equals 8. So x equals 4. And that is our answer if it works. Let's check that out. Let's substitute that into the original equation. And that's our original equation. And so why don't we substitute 4 in where all of our x's are. There you go. And we have root 3 times 4 minus 8. And minus root 4 equals 0. And I'm going to walk through this whole check with you because it just got so complicated. 3 times 4 is 12. 12 minus 8 is 4. Root 4 minus root 4 is 0. So 4 is a good answer to that. And do your homework.